Hi everybody. I decided to go ahead and to try this again and see if it will help, especially for those people who were absent today in class or you had some problems for today in class. So first of all, we did the warm-up on 3.3, number 1 on the warm-up. Basically, all you did was look at these two, read the information, and then go ahead and it says, do you think the attraction will be harder to get the strong magnets to change phase, and explain. Go ahead and finish this, and then please go ahead and hand it in. You can stop this video, go ahead and do this, and we'll move on. The next part that we're coming to is for me to actually play this video, and unfortunately I can't save a link to this for you, so we're going to look carefully. And it's showing you that the magnets on the weak side, those are those colored marble magnets that we used last week. And then the ones on the right-hand side, the strong side, those are gray ones. And they're a lot stronger magnets, so they hold together a lot tighter. Okay, so as they shake the magnets back and forth, the energy the kinetic energy put in are exactly the same. But you can see that the molecule movement, as far as in the weak side, they're moving away a lot easier than in the strong side. So during the strong side, they bond more closely together. So again, it takes a lot longer and a lot more kinetic energy to pull those magnets, just like their molecules that have a strong attraction. It takes a lot more to kinetic energy to actually pull those apart. Next, you're going to go to 3.3, number 2. And on number 2, okay, it says on the next 3 screens, okay, you're going to find evidence from the SIM or the magnetic marbles or the liquid oxygen that you read. And down at the bottom here, you see that you have different numbers. So if we're going to go to number 2, okay, you need to choose, if you were absent, you need to choose one of these in order to go ahead and to fill in the information at the bottom. It can be either number 2, number 3, okay, which is talking about the marbles and filling in again the information, or number 4, and this was your article on liquid oxygen. So choose one of those, go ahead and do that, stop the video and come back. Okay, and hopefully you handed that information in. The next thing you're going to is the modeling attraction. And this is where some classes we didn't get to do this, so I'm doing it online here for you. And so once you get into this, let me start from nothing again. Okay, you're going to go ahead and it asks you, your directions say that if, for instance, for us, we talk about the methane lake in the beginning. So we take the methane lake here, and it wasn't a solid, but it was a liquid in early 2002. That was the beginning of summer for Titan. And then we had in 2007, it was still a liquid. Okay. However, we know that energy went in, okay? So first of all, we'll go here, and we know that it was a lake, okay? And so it is a liquid, okay? And liquids move around each other, okay? And liquids fill, or have, where are we? It takes the shape of a container, and liquids stay at the bottom, and liquids flow. Okay, and so then that is our first one. Okay, and then we have our second one here. This was in 2007, and so it's still a liquid. It's still, molecules are moving around each other. Okay, and we still have that it flows, it takes the shape of the container, and it stays at the bottom of the container. All right, I know I have not done anything to the attraction yet, okay? Because what we found out was through the activity is that the attraction level obviously is a stronger attraction because it's taking longer for it to pull apart from those molecules to go from a liquid into a gas. So it says a change in kinetic energy, actual, and what we need. So what we had here is the change, and we're going to go ahead from these two lines, and we knew that energy was transferred into, okay, it's still a liquid, but we know from 2002 to 2007, the early stages of summer in Titan, okay, to 2007, energy was being transferred in. But what we need is we need more energy to be transferred in, okay, for it to actually have a phase change. So how much energy? It needs more than what we have right now. So then again, attraction allows attraction to overcome the energy, or allows the energy to overcome the attraction. And we need the energy to overcome the attraction. So this is what we have. So therefore we know that, going back here, okay, it must have a high attraction with those molecules, since we have to have more energy transferred in, more kinetic energy transferred in. So this again shows you what your final part would look like. So if you will go back to your part, okay, and excuse me, and go ahead and do your sim, follow the directions on what it says for you to do, okay, and go ahead and upload your image. Go then to number 4 for your homework, and on number 4, okay, you're going to use a word bank. Okay, you're going to write a letter to Dr. Flores, okay, stating, okay, up here, remember, stating why or how something happened. Might use the terms such as because, therefore, since, this was caused by. Will state important causes and effects, providing evidence that supports the ideas. If helpful, use the words from the word bank. You do not have to use them all, but you do need to make sure that you're reviewing the modeling tool that I just went over, okay, for you to write that information. Also, I would use the information from the key concepts that we wrote today, and also that you have in there, explaining again why energy had to overcome those molecules in order to pull them apart, in order to have a phase change into a freedom of movement, going from moving around each other to going to moving away from each other. All right, and then you're going to press next. Okay, and you have an article to read, okay, in regards here to this information about Mars and pressure and temperature. We did not do this today. We are not doing this as part of homework today. We will be doing that tomorrow. Hopefully this helped you. Have this all completed, with the exception of the article, tomorrow. Thanks. Have a good evening.